I hereby promote you to Platform Architect. And your first job is to decide for our new React Competitive View framework what kind of state management system we want to use, how we want to interact with the state associated with every component. Now you've got three basic options here. The first is the proxy option. So our state manager is going to return an object proxy that you can then just set. So in this case, we've got a name editing component. And in order to set the name with a new value, we just set the value. Pretty easy, right? So that's option number one. Option number two is the deep copy option. This is where we're going to go and set the value directly on the object. And then we're just going to send back that object to say that we have mutated the state somehow. A little bit more clunky, I guess. Option number three is the reference option. We create a new user using a shallow copy using the spread operator. Then we set the name to the new value, and then we send the new object to the state system, and that indicates that there's been a change. Those are the three basic options that you have when it comes to the developer experience of setting values in these kind of view frameworks. So which one do you think we should use? And keep that in mind as we talk about how to implement each one of these different strategies, and we'll use React as a basis for our implementation. And why are we doing this? Well, we're doing this to learn more about why React chose the reference model, which might not seem to you to be the one that you would have chosen for your state management system. And speaking about learning, Brilliant is a sponsor of this week's Blue Collar Coder. I'm really excited by that because it's my favorite place to go learn more about them in a bit. Let's get right into it. I'm over here in my VS Code, I got my terminal open, and we're going to build three different versions of this application to show the three different methodologies for this state management. All of this code is available to you on GitHub for free, as always. There's a link to that in the description right down below. Let's start off with our proxy version. I'm going to use Vite to create that. So I've got the proxy version folder over here. I'm going to go CD in there. I'm going to install it and then run it. And it looks good, but it's got a lot of boilerplate in it, so let's go get rid of all that stuff. So I'm just going to remove a lot of this. And I'm also going to simplify a lot of the CSS. So I'm just going to get rid of the app CSS, and I'm going to simplify that index CSS by just saying that we want some big fonts and we want to pad it in a little bit. All right, so to start off, let's start off with our JSX. And in here, I'm going to have a div, and then within that, we're going to have an input, and it's going to have the username. And then we're going to have an on-change name, which is going to change that name, and then we're going to display that name. Now, we need a way to track that user. That's the whole idea. So in order to do that, we are going to create a use proxy, which is going to use the JavaScript proxy mechanism to manage that state. So let's create our use proxy. Use proxy is going to take an initial object, and it's going to return a proxy. Now, the next thing we do to our proxy is our handlers. And those handlers are a set of methods that get called when you either set or get a value on that object. So let's start off with get. Now get takes the object and the key. And the easiest way to satisfy that request is just to call reflect.get and give it the object and the key. So we can actually simplify that a little bit and just say that we want the arguments to this function to go to reflect.get. And then we need a set function. This function takes the object, the key, and then the new value. But we can do the same thing with reflect and just call reflect.set with the arguments. And then we return true to indicate to JavaScript that something has changed. Okay, so next we need to use this. So we're going to use this proxy, and we're going to give it the name John and say that they're a developer. Now the input value has been satisfied, so we need an on-change name. So we should just be able to take the event and set that to the username and see. So let's give it a try. All right, so nothing is working. So what's the problem? Well, one of the problems is that React doesn't actually know that anything has changed. There's no state associated with that component yet. We haven't used useState, so there's no way to indicate to React that something has changed. So what we need to do is create some dummy state that we can then just bump anytime that value changes. So we'll create a new piece of state, we'll set it at 0, and then we'll get back this set dummy that we can then use to just bump that value. Now after the set, we can call set dummy. And we just give it a function. The function says, hey, just bump the value by 1, and it goes up, and that indicates to React that something has changed. So let's hit save and try this again. All right, it's not blowing up, but it's still not working. So what's the problem here? Well, the problem is that every time we set dummy, app gets rerun. That then calls use proxy, and that returns a new proxy with the original value. So we're not actually changing anything. So what we need to do is create that proxy once and then reuse it. To do that, we're just going to use ref. So we're going to create a proxy ref using useRef, and then we'll just give it that initial value of the new proxy, and then we'll just return that proxy ref current. All right, let's give it a try. Hey, that's pretty cool, right? Now let's go and add on our profession just to make sure that that doesn't get nuked every time we change name. And it looks good. Awesome. Okay, so this is great. From a developer experience standpoint, I can just change name and it just works. Why wouldn't I want to go with this? Well, there's two primary issues when it comes to proxy. The first is that it is a shallow proxy. For the given object, in this case, this one right here, setting name is fine, setting profession is fine because they're at the first level of this object. If we were to go and create another level, say address, city is Portland, and then we go down here and we show that, and we have a way of editing it. And then we have our city change. That's going to go set that value to the new event value. All right, let's give this a try. If I set Portland, nothing seems to work, but if I set John, it does work. Now we got a little bit of a hangover here because we set the value, but we actually didn't get a callback. So yeah, that's just not great. The issue here is that the first level of this object, name and profession and address, are proxied, but the interior of address is not proxied. So in order to fix that, what we'd have to do is have get return a proxy, and it would need to manage all of that. And that just gets really complicated really fast. There's some good proxy-based state managers out there like MobX and Valtio, but they both have similar issues where if you don't use them exactly the right way, you lose the observability of parts of your state tree, and that just becomes a hassle. The other problem is you can't proxy the primitive types like string, number, and Boolean. So you can't just have like use proxy 0. What you'd have to do instead is have use proxy, you give it an object, that object would contain a value, which is itself a number, and then you'd have to bump that. So it's not great. The other issue is kind of a legacy issue when it comes to React in particular. React started with class components. Class components had state associated with them. In order to set that state, you would just do this.setState. And that state mechanism was not proxy-based. So when they wanted to move to hooks with functions, I think that was a consideration that they had to take into account, which is they didn't want to change the basic core mechanics of setting state so drastically from a non-proxy-based system to a proxy-based system. So now that we've learned about proxy-based state management, let's learn about this week's sponsor, and that's Brilliant. Brilliant is a fantastic place to learn new skills. I'm learning data sciences, and the way that I'm learning data sciences through Brilliant works really well for me because I'm not the kind of person that learns by just reading some text and then taking quizzes on those tests. I'm dyslexic. That doesn't work for me at all. What works for me is getting my hands into things. It's called constructivist learning. That's why I like to play around with stuff. And that's exactly what Brilliant allows me to do. When I'm learning data sciences, which is what I'm interested in, I can go and change the parameters of what's on the screen, and it's interactive, and I can learn things like the difference between the mean and the mode and how means work by just simply manipulating the data, and that helps me retain all of that information. To be really honest with you, yes, they're sponsoring this video, but I can't honestly think of a better place to learn math and science and data sciences and AI than on Brilliant. It's just a fantastic platform, and they put so much effort into making it easy to understand these difficult concepts. If you, like me, struggle with learning some of these concepts and you think an interactive approach would help you learn them, and I think it will, then try out Brilliant at brilliant.org/Jack Harrington. The first 200 of you will get 20% off on your subscription. So now that we've learned about both Brilliant and proxies, let's talk about the deep copy option. So let's go and take this example and create a deep copy version. All right, now I'm going to go launch the deep copy version. Okay, so we got our deep copy version. Now I'm going to create use deep copy as opposed to use proxy. So within here, we don't need a proxy. So we're not going to use ref. And we do want to track this object. So we're going to use that as the use state. So we'll call this the original object. Now from our use deep copy, which we're going to use down here, we are going to get back the current user and a way to set the user as functions, just like we would do with use state. But we want to just be able to say set user and then give it user, the same user, in both places. So now we need to start talking about what React is handling in terms of state management. React has three primary responsibilities in terms of state management. The first is to just hold the state, in this case, use state. The second is to allow us to mutate that state. So in this case, set state or set original. The third thing it needs to do is compare the new value that's being set to the old value. The reason it needs to do that is for a performance optimization. It needs to say, well, if you're setting the same value twice, I'm not going to re-render. So how are we going to simulate that here? Well, let's imagine a hypothetical pack of trading cards. I give you my trading cards. You then maybe make some changes to it. Maybe you add a card, maybe you remove a card, and then you give me back that pack of trading cards. Well, how do I know if you made any changes? Because there's only one pack of trading cards in play. Well, what I need to do is have some way of accounting for what's in that pack of trading cards, like a list, or honestly, the easiest thing to do, if I could, conceivably, is to just clone that pack of trading cards and then give you the clone. You can then do whatever you want to it. Then when you give it back to me, I can compare your clone to the original that I had. And then if that pack has changed, I can then use your new version as the canonical original version. So how do we simulate that in React? We can use Lodash for that because it's got some great utilities. The first one is clone deep. And so what we can do here is return an array, and that return has in it a clone deep of the original. That's me giving you a clone of the set of trading cards. And then for set, we give you a function. It takes a new value, and then we set the original to that new value. So far, so good. So we have a way to hold state, and we have a way to set state, but we don't have a way to do that performance optimization. We want to take a look at the contents of the original value and compare those to the new value coming in to make sure, have they changed? Well, there is a good way to do that. It's called isEqual. IsEqual is a deep comparison. So you give it two values and it tells you whether they're different. So we can say if not isEqual and then give it the original value and the new value coming in. Then we know that we want to set that original value to the new value. Okay, looks good. Let's try it out. And it works just fine. Okay, so now we have a deep copy-based system. We can just go and set values on user and set that user, and it works. Okay, now in order to do a good comparison between the proxy version and the deep copy version, we need the reference version as a reference. What does React do as opposed to all of this? So let's go and build the reference version. Okay, now let's go over to the ref version. And we only need use state at this point. But of course we know that this set user isn't going to work because we're not changing the reference to user. So what we need to do now is create a new user value with all the existing user. And then we need to set the name. And then we need to use that new user to set the user. We'll do the same thing down here for our address. But in this case, since address is an object, we want to clone that existing object as well. And then set the city. And there we go. Okay, let's try it out. Awesome. Cool. All right, so now we have the three different versions completely implemented. So now we have on this side the reference version, which is what we get in React today. And over here we've got the deep copy version. And I gotta say, developer experience-wise, I might pick that deep copy version. I mean, look, I just got to go and set user.something, and then I set user. That's okay. I can deal with that. And it works. I can even do it at a deep level, and it's fine. Whereas over here, I got to do all these spread operators, and I've heard that the spread operator might not be performant because there's some article out there talking about how the spread operator isn't performant. I don't know. So, okay, I think the point right now would be to go and compare these two at a performance level and see which one actually works better and faster. So let's go ahead and do a performance evaluation of deep copy versus reference. So I'm going to create a new directory called performance. And into there, I'm going to create a project. And then to that project, I'm going to add Lodash, as well as Faker. Faker is going to allow us to create some simulated data. So let's create a file called perftest. And into there, I'll bring Faker. And with Faker, I'm going to create a new function called createRandomUser. And it's just going to give us back a big old object that has a user ID and a contact and all this. And we're just going to go and build out a random user. Now we're going to create two versions of an add and compare function. So this add and compare function is going to create a new value, in this case, new user. It's going to take all the original value of a user. It's going to add a value, in this case, name. And then it's going to say, hey, are these two things different? And obviously, that's going to return true because we're comparing new user to original. Those are two different objects. So obviously, this is going to compare to be true. But this is, in effect, what any kind of on change is going to do. It's going to create a new object, and then React is going to do the comparison of those two things. Now let's do the same thing for a deep copy. So in this case, we're going to take the original. We're going to do that clone deep that we did before. We're going to set the name, and then we're going to do that is equal. So this would be handled by our framework, the clone deep and the is equal, but the mutation would be the on change code. So this is doing the deep copy version, and this is doing the ref version. Now to performance test these, we need a performance testing function. So I'm going to add a function called performance test. It's going to take the function that we have here, so add and compare reference and add and compare copy, and then it's going to run it 100,000 times. So it's going to create a random user, and then it's going to create 100,000 copies of that user using clone deep. And then we're going to start a timer, and then we're going to run over that whole array, and we're going to pass each one of those users to our function, which is going to do the mutation. And we're going to see how fast did that work by comparing the time at the end to the time at the start, dividing by the number of iterations. And that's going to give us the time in microseconds for each operation. So let's start that off with our reference version by just doing a console log. And we're just going to say the reference comparison version. We're going to give it the performance test, multiply it by 1,000, because actually we get this in nanoseconds. So we're going to upscale it to microseconds. And then we're going to give it 3 digits of precision and say that that's the microseconds version. So let's try this out. Perf test. Clone deep is not defined. I forgot to bring that in. Let me just bring that in real fast. Okay, let's try it again. And we get 0.2 microseconds per operation. So it takes 0.2 microseconds to do this operation. Okay, well, we don't really know yet because we haven't compared that to our deep copy. So let's try the deep copy version. Pop that in there. Exactly the same thing. We give that function, we multiply it by 1,000 at the end to upscale it to microseconds, and then we format the result. Okay, let's give that a try now. And now we can see that that deep copy version is 10 times slower, which is pretty obvious when you think about it. We are doing an entire clone of an object, and then we're doing a deep comparison of that object. And honestly, that's why React went with references. It's just a whole lot faster to compare two different memory locations than it is to do a comparison of all of the data within an object. And in order to create that comparison, in order to allow for that comparison, we actually need to clone that object. So yeah, that's going to be a lot slower. All right, well, I hope this fairly esoteric deep dive into understanding why the React authors decided to use a reference-based option when it comes to evaluating state changes in React, as opposed to something that may have a nicer developer experience like a proxy or a deep copy. All right. In the meantime, if you like this video, be sure to hit that like button. And if you really like the video, hit the subscribe button and click on that bell and be notified the next time a new Blue Collar Coder comes out.